For problem number 1, we're being asked to graph y equals negative 1/3 times 3 to the x. And before we even start graphing, or even before we start making a table of values, there's a couple of things that we can learn from this, from just the equation. So looking at this 3 in the spot for b, we know that this is going to be growth. So we can see that we're going to have a graph that goes from bottom left to upper right. That is, until we get to the a value. And the a value tells us that because it's negative, it's going to be flipped over the y-axis. So instead of looking like this, it's instead going to look like that. Then the other part that we know is, since the a value is 1/3, it's going to be compressed. So it's going to get smushed up a little bit. Now, because there's no h value and there's no k value, we do know that negative 1/3 is going to be our starting point, or is going to be the y-intercept. So if we were to plug in 0 for x, 3 to the 0th is 1, times negative 1/3 is negative 1/3. So again, what we see is that as long as there's no h or k value, the a value is always going to be our y-intercept. The only time it's going to be different is if we have an h or a k that's moving it left or right or up or down. Then we've got to do some math to figure it out. So again, what do we want to do here? We want to check, and we want to get some numbers that we can put in for x that will then give us a y value. So let's go ahead and go with -2, -1, 0, 1, and 2. If we put in -2 for x, then we're going to get 1 over 3 squared. So 1/9, then times negative 1/27, or 1/9, then times negative 1/3 will give us negative 1/27. Then if we plug in 1, or -1, 3 to the negative first is 1 over 3. So 1 over 3 times 1 over 3 is going to give us negative 1 over 9. If we do 3 to the first, then it's just going to be 3. So negative 1/3 times 3 is negative 1. And then if we do 3 squared, we're going to get 9. So negative 1/3 times 9, or 1/3 of 9 is 3. And since it was a negative, it's going to be a -3. So you can see this is what we've got, our 5 values here, and then we can go ahead and just graph these. So -2, negative 1/27, that's going to be as close to that y-axis as I can get. Then -1, negative 1/9 is still going to be very, very close to that y-axis. 0 and negative 1/3, still pretty close. 1, -1, starting to move away, and then 2, -3, finally pulling away from that y-axis. So there you can see that that is the general shape of the graph, and the y-axis is still going to be the horizontal asymptote. In problem number 2a, we're being asked to graph y equals 2 to the x minus 4. So before I do any sort of stuff with the table or anything with the graph, what I want to do is I want to see, is there anything that the equation itself is telling me. So I look at this b value, and I already know that this is going to be exponential growth. So it's going to be starting bottom left and going to upper right. And then I can see that I've got an x minus h with an h value of 4. So that tells me that the parent graph is going to be moving 4 units to the right. There's no k value, so there's no up or down movement, and there's no a value, so there's no stretch, compress, or reflect. Now, what I want to do first is I personally want to find out what is the y-intercept. So remember that the rule for the y-intercept is it's the value of y when x equals 0. So if we put 0 in for x, then what we're going to end up with is 2 to the negative 4th, which is 1 over 2 to the 4th, which is 1 over 16. So the y-intercept is going to be 1/16 this time. So now you can see the effect that the h value has had on the y-intercept. Normally it would just be 0, 1 on this one, but because of this h value, we've now moved it to 0 and 1/16. Now what I want to do is I want to figure out what's going to give me an exponent of -2, -1, 0, 1, and 2. So if I want to get -2 here, then I'm going to put in a 2. If I want to get -1, then I'm going to put in a 3. If I want to get 0, I'm going to put in a 4. If I want to get 1 for the exponent, I'm going to put in 5. And if I want to get 2 for the exponent, I'm going to put in 6. Now, why am I doing this? These are just the points, or these are just the values that I want to put in because I'm just so used to using -2, -1, 0, 1, and 2 that for me it just makes sense. So when I do this, if I put 2 in for x, 2 and -4 is going to be -2. So 2 to the -2 is 1 over 4. And it would actually help if I put these in the correct column. So 1 over 4 is what I get for 2. Now I'm going to try 3, 4, 5, and 6. So for 3 minus 4 is -1, so I'm going to get 1/2. 4 minus 4 is 0, so 2 to the 0th is 1. 5 minus 4 is 1, so I'm going to get 2. And then 6 minus 4 is 2, so 2 to the 2nd is 4. So now I definitely have plenty of points here that I can graph. So I'm going to go 0, 1/16, 2 and 1/4, 3 and 1/2, 4 and 1, 5 and 2, and then 6 and 4. And again, you're going to be able to see the shape of this graph. It's going to get closer and closer and closer to that y-axis, but it's never going to touch it. And then as it starts making this curve here, going around the curve there, it's just going to get steeper and steeper and steeper. So this is how you graph y equals 2 to the x minus 4. In problem 2b, we've been asked to graph y equals 20 times 1/2 to the x plus 10. So we're going to have quite a bit of movement with this graph because of all of the numbers that we've got going on here. So let's start with the b value. The b value is 1/2, so that tells us it's going to be decay. So instead of looking like this, the graph is instead going to look like that. The a value is 20, so we know that it's going to be stretched a lot. It's not going to be reflected though because it is positive. Then this 10 tells us that we're going to move up or down. We're going to move up 10 units from where the parent function would have been. So one of the things that I want to do first is I want to figure out kind of where is my y-intercept at. So I'm going to start by plugging in 0 for x, because remember that the y-intercept is the value of y when x equals 0. So if we do that and put in 0 for x, remember anything to the 0th power besides 0 is going to be 1. So 1/2 to the 0th is 1 times 20 is 20 plus 10. We end up with 30. Now I want to go ahead and do -2, -1, 1, and 2 to see what my other values will be for when I go to plot this on the graph. So if I plug -2 in here, I get 1/2 to the -2nd. Well, that negative exponent is going to flip it. So it's going to become 2 squared, which is 4, times 20, which is 80, plus 10, which is 90. Then I've got 1/2 to the -1st, so again, flip it. 2 to the 1st is 2, times 20 is 40, plus 10 is 50. Go to the 1st, so 1/2 to the 1st is 1/2. 1/2 of 20 is 10, plus 10 is 20. And then 1/2 to the 2nd is 1/4. 1/4 of 20 is 5, plus 10 is 15. So what I know is that I can't just use 1s for my tick marks here. So what I'm going to do is go by 10s. So I'm going to make that 10, so I've got 10, 20, 30, 40, 50, 60, 70, 80, and 90. So lucked out, and I have it all the way up to 90 there. So I've got -2 and 90, and then I've got -1 and 50, so 10, 20, 30, 40, 50. I've got 0, 30, 1 and 20, and then 2 and 15. And what's going to happen is this k value is now going to represent the horizontal asymptote. So y equals 10 is going to be the new asymptote. So I'm going to mark this off and make sure that I don't cross that y equals 10. And there's your graph for y equals 20 times 1/2 to the x plus 10. Another formula that you're going to want to know is A of t equals PERT. Now what this is it uses E, which is the natural base. This is something that you're going to have to use a calculator for because you're not going to be able to calculate this on your own. Now what we use this for is for continuously compounded interest, or we'll use it for prediction models. But basically the way it breaks down is we've got the amount after a certain period of time equals the principal, or the amount that you started with, times the natural base, and that's going to be raised to the product of the rate and the time. And again, remember, time is going to be in years, so if we need to do months, we're going to do something over 12 to determine that amount of time. So if you were looking for the amount of money you would have in a continuously compounded savings account after 10 years, then 10 would be your T. You would put that in right there. You would have to be given a rate, say like 4%, so 0.04, and then you would have to have the amount, the initial amount. Put this into your calculator, and it's going to give you the amount there. For problem number 5, we're given a word problem that says that when you were in elementary school, you won a contest and you were given $3,000 that was put into a savings account or a scholarship fund or something along those lines, and it was going to receive 5% interest for 4 years. And you want to know how much is going to be in that account after those 4 years. So we're going to use A of t equals PERT to determine that. So our A of t is going to become A of 4 because we want to know how much is going to be in that account after 4 years. The principal interest was $3,000. Then you have the natural base exponent, and then 5% is going to be 0.05, and then again your time is 4. So we've got to start with the product of the rate and time first, and that's going to be 0.2. So you get 3,000 times e to the 0.2. When you work this out, you're going to have approximately $3,664 in that savings account after 4 years.